Hello everybody, what's up? It's Papa Bale and welcome to the channel. So what we're looking at here is a 9 magnet rotor with 40 millimeter by 20 millimeter N52 Neos. There's 9 of them, 40 degrees of separation at, I believe this is a 10 inch, if not a 9 inch rotor. Probably a 10 inch. So at 10 inches, 40 degrees would be about, I don't know, an inch and a half distance between each magnet. It's pretty awesome. I think it's timed pretty well for what it does. It's nice. There's enough space in between each magnet. There's a magnet's worth of space in between each one. So there's perfectly enough room to put another magnet in there and then be side by side. All right. That's the rotor, and it's pretty smooth. The input here is 6.35 watts, basically. And it's all going through this coil right here. It's a tri-filar coil. The 18 gauge has got the 6.5 watts going through it. And then we got a 32 gauge trigger. And it's firing this transistor down here, which has a standard output. That's the extra clips you see, the blue and the yellow one right there, for the ground, and the output charge for the battery right here. Because when I hooked the tri-filar and the output, I had to put a diode in. It's right here. I had to put that diode in because it didn't, it kind of went right through everything without it. So that, and it works. It'll probably be charging a little bit faster. I'm not, I mean, maybe you should quote me, I don't know. Charge a little bit faster if I took the diode out. But I put it in there for a reason, so it won't charge faster. It'll stall out. All right. I don't know. I like to look at all the angles. All right. Where were we? Tri-filar coil. 20 gauge is the tri-filar strand. It's hooked up directly to this cap bank. And this cap bank is connected directly to this battery. I call it an ACDC cap bank. That's what we're going to call it because it's got the AC caps. Then it got some bridge rectifiers. And it's got DC caps. So the ACDC cap bank. And as you can see, this is the cap bank. The big cap bank is charging at a slow rate, but a steady rate. Very steady. Nice. Then the battery is what this cap bank is charging. So this coil right here, this one, is charging the battery. It's all dedicated to the battery. All of its charging power mechanisms. Because the battery with its capacitance for 20 amp hours is huge. I mean, it's going to take a lot to charge it. Alright, so, but you gotta remember, we're keeping it low. We're keeping the voltage low. It's just above low voltage, so it's just above 5 volts. 6.34. So, we're not getting a lot of output at this point. Because, I mean, I do understand that for the most part it's a 12 volt system. So you put 12 volts in, and the spike at 12 volts is going to be The collapsing spike at 12 volts is different than the collapsing spike at 6 volts. Okay, like way different. um, so yeah, I mean, it's moseying right along. It is going up. But in order to get any of that big, spike, you got to put in some voltage. And then this coil, I believe, is the only one that's going to get that spike, that collapse spike, because it's the only one that's got power going through it, or being put into it. These other ones are merely pickup for AC generation, and that's why it's charging the cap bank so slow. This is a 26 gauge coil. It's not like the 32 gauge coil, which would have been nice. That would be a nice fat 32 gauge coil, man. That'd be generating mad voltage. But, gotta work with what you got. But, I mean, this one, the 26, I think it's like 6,000 turns of 26 gauge. Like 6 strands of 1,000 turns apiece. It's bumped like all the way out to the edge of that bobbin, and that bobbin has got to be at least 1.5 inches radius with, I don't know, 3/8 of an inch for the core, for the axle. That is a lot of wire in there. That coil weighs a lot. And then the other one over there is even more turns. It's like twice as many turns as this one. But it's a tighter wrap. I used a different winder. So it's a tighter wrap. And it's 32 gauge. Really neat. And then I just connected those two in series. And then I connected those to this cap bank over here in series. So it starts here at the cap bank, it goes in to this coil, out this coil to this coil, and from this coil to the end of the cap bank. And there you have your little AC dump right here to the cap bank. And then it comes out the other side as DC. Nice. It's cool, man. And then, it does stack. It's enough DC to push forward whatever resistance the cap bank is bringing forward. So that's awesome. And I mean, it doesn't look like it's putting much of a slowdown on the rotor. Oh, and there's this one more thing, man. This rotor. And we're going to look underneath it real quick. You see how it's got the toroid? Let's zoom in on it. Okay, that toroid and the one on the table are set to attract to each other. So I have a little stack of bearings. And it's stacked higher so they won't touch. Yeah, so they won't touch, and it's keeping it really stable, and it's surprisingly not getting in the way of motion. It's pretty clever. Anyway, thank you very much. Peace out. Have a wonderful night. Bye now.